Ladies and gentlemen, please welcome Docker's CEO and Chairman of the Board, Steve Singh.
Good morning. Good morning. All right, I love it. I like a little interaction. So look, first of all, thank you to everyone for taking a week out of your schedule and coming out and spending time with us. We're going to make sure you have an absolutely fantastic program, you get a lot out of it, you have a lot of fun along the way. So officially, welcome to DockerCon 17 here in the beautiful and historic city of Copenhagen. You know, look, only a few short years ago, Docker was nothing more than a dream for our founder. Today, there are more than 10 million members of the broader Docker community. And look, the majority of those members really just joined in the past few years. In fact, I'm going to ask, how many are new to DockerCon? A show of hands. Wow, that's a lot. That's fantastic. Look, it's inspiring to see the diversity of experiences and interests, and frankly, the people that are working with us to build what we believe is a foundational element of the next generation of computing. And by the way, that foundation is not merely a container. It's a platform upon which all of us can innovate at a global scale. Now, I happen to be one of the new people to join the Docker community. And so it's especially nice to hear the applause this morning. I was thinking, okay, new crew, I have no idea how this is going to go. So, look, I want to take this opportunity to introduce myself and share why I'm excited about Docker. But perhaps just as importantly, I want to share what I think Docker and this incredible community can deliver to the world. So I happen to be coming to Copenhagen after spending a few days with my extended family. And this, by the way, this is something that just gives me incredible happiness and incredible joy. Right? My favorite part of those gatherings is really at the end of the day, sitting around the dining room table, just enjoying great food, great wine, and just listening to the stories of, of my family. And for me, as I look around the room, around the dining room table, I always get this incredible feeling of joy and contentment as I listen to the hopes and dreams of the people that I love. So as it turns out, though, you're probably wondering what that word up here is. As it turns out, the state of being or the state of mind that I'm describing is actually really well known in the Docker community. I'm sorry, in the Danish community. That's what I meant. It's also well known in the Docker community. What's going to be well known in the Docker community. The phrase is hygge. Have you guys heard this before? Now, I'm sure I have butchered the pronunciation, and for that I apologize. Okay? But I do identify with the meaning of the phrase. Hygge refers to a form of togetherness, right? Based in equality, and I'd like to think it's also based in an appreciation for the potential of other human beings. It's a beautiful way to think about the women and men of the Docker family and the broader Docker community. And frankly, I think that's what makes Docker incredibly special. So, look, I'm coming to Docker having spent the past few years at SAP. In fact, on the SAP executive board, running most of SAP's cloud businesses. I joined SAP after it acquired my company, Concur. And Concur, look, it was around for about 20 years or so, right? And in that 20-year horizon, we built one of the largest software as a service companies in the world. Now, over that time, it's amazing to see how much change that we've seen across the entire technology industry. Because it literally permeates not only every part of our lives, it permeates every part of every business that you are ever going to be involved in. And of course, change is a constant in technology. And hopefully, no one knows that better than you folks do. It's a little warm up here. So look, even as we're benefiting from the changes that come from moving from a PC-centric world to a cloud-centric world, right, we're already seeing the potential that's going to come about from a world of distributed applications and distributed computing. In fact, I think it's distributed intelligent applications, right, as they get completely rewritten over the next 20, 30 years. Now, that feeling of change, well, look, it's disruptive, it's uncomfortable, right? It pushes you outside your comfort zone. but it's also, in my view, one of the things that gets you really happy. It's one of the things that gives you excitement, because this is what you can go focus on. This is the value. This is the foundation upon which you can build incredible value. For me, though, throughout all the changes that I've seen in my career, and by the way, I started out programming on the Apple Lisa, right, a long, long, long time ago. Right? But throughout all this change, there's always been a constant for me. And it's really this. It's a way of thinking about the world that has served me well. It's also an approach to life that I firmly believe in. You have to imagine the way the world should work. Not the way it does work, or not the way it's best for you or your company. All right? You have to imagine how should the world work, or at least your little corner of it, and make sure that you think about that in the right context, which means that that approach, if you look at it from the point of view of how the world should work, it has an incredible advantage for you. That approach allows you to think about that opportunity without any of the trappings of historical success. And by the way, you think about most companies, the biggest transition problem they have is their own success, right? Incredibly successful for decades. And that success drives the momentum. How you navigate to the next opportunity, next success, really is influenced by your current success. Imagining the way the world ought to work is a framework that allows you to say, let me put my interests aside, think about how the world should work, and let me go drive towards that, without any objective of how we benefit from it. Taking that approach not only allows you to set the right framework, frankly, in my view, it gives your company a chance to actually have a framework from which it can operate. At Concur, this always served as our North Star. And look, I'm a guy who was literally born in a mud house in a tiny village in India. So I'm very comfortable with the idea of thinking about how the world should work, not being limited by how it does work today or what the circumstances I was a part of. I'm going to ask you guys to switch to the next slide. Somebody back there, there you go. Look, over the past several years, I've also had the good fortune to meet with CEOs and CIOs from virtually every industry and literally across the entire planet. What I heard was very consistent. And what I heard is why I believe Docker and the Docker community is so important in the years ahead. In fact, I believe Docker has a front row seat as some of today's most interesting business problems. Let me share with you some of those data points. Most of the CIOs I meet with, in fact, it's not just the CIOs, it's the entire organization. Most of them start every fiscal year with 80 to 85% of their budget already spoken for, which means you don't have a lot of room to invest in innovation. Right? And every company that you ever speak with is also tasked with driving innovation to go compete in a world where the boundaries between industries are starting to disappear. Frankly, where competition is starting to come from every single direction. The other thing that was really interesting was every company I met with saw the role of software, both purchased and also, frankly, internally built, which was the lion's share of their thinking. They saw it as critical to their future. And that was really important. Right? That, by the way, is the foundation upon which all of us share. Right? It's the foundation upon which we will go build the next generation of computing. So I'm going to share a couple of stories within those three contexts. In fact, look, a long time back, I had a discussion with the now retired CEO of Delta Airlines. He held this view that for Delta to compete on a global basis, it had to become what he called a software company with wings. Right? Now look, that was a very telling insight, right, into how he thought about his business and frankly how he thought about his industry. He was pushing manufacturers of airplanes to give him a digital twin of that airplane. The reason for this is very simple. He wanted to be able to manage his entire fleet, understand what was going on, and manage his entire fleet on a real-time basis. But by the way, think about that for just a second. That is edge computing. That's mobile edge computing. That's a real-life case that we're all trying to solve for. NCR, National Cash Register. It started out as the world's first mechanical cash register. And today, it's the global leader in point-of-sale systems and, frankly, ATMs, automated teller machines. But as the world went digital, as purchasing moved online, and as payments moved online, NCR had to go to a multi-channel solution, right? How do you deliver a point-of-sale solution that's multi-channel? But here's the thing, even as that team was executed really well against that vision, against that objective, the world's already starting to change around them. Right? Payments are starting to aggregate in software touchpoints. So when Bill and team think about how they run NCR in the future, they're starting to think about NCR as a payments company, as a software company. And they're looking and saying, how do we build incredible software to go be relevant and add incredible value to our customers? BMW and Volvo, fantastic car manufacturers. In fact, both of them, I believe, are here today and customers of Docker. They're not only some of the most innovative car manufacturers in the world, they're not just grappling with the shift from gasoline-powered cars to electric-powered cars. That's the easy part of the transition. What they're grappling with is what's the role of an automobile manufacturer in a world of autonomous drive cars? Which, by the way, this will happen not just in your lifetime, it's going to happen within your career. I drive a Tesla. I tell you what, I love it. Half the time, I can let it drive itself. Half the time. Not entirely. The question for car manufacturers is, what does this do to their business models? Right? Will Uber or its equivalent be the decision point on which car you actually use? Will you and I actually even be the primary buyers of cars in the future? Or is it going to be a fleet producer or a manufacturer? Look, it's the same thing. Think about where servers are purchased today. Right? Go back 10, 15 years ago, corporations were the biggest buyers of servers. Today, that's certainly not true. In fact, look, it's hard to think of any industry that isn't facing disruptive technology-led change. And my view is because of that, the role of IT is changing radically. In fact, I think the IT organization, right, which we all represent, the IT organization will be just as strategic to a company as this product organization. And this is for a very simple reason. Every company in the world will become a software company. Every single one of them. Because world-class products, the things that they're going to deliver, they're going to be delivered through incredible software and incredible customer experiences. Okay? Or if I can borrow from Steve Jobs, right? Companies will evolve to wrapping their incredible products in a beautiful software experience. So the question is, how does that happen? How does your company become a software company? Well, look, obviously we have a point of view on this, and I'm going to let you guess what that is. Look, just as the physical container modernized the global supply chain and ushered in a new era of commerce, digital containers are going to modernize the software supply chain. And it'll usher in a new era of globally integrated software and commerce. Are you guys with me? All right. Come on now. Look, that software supply chain will not only seamlessly integrate a company's developers and testers and operators, it's going to integrate and connect you to the rest of the world. Right? It's going to, whether you're talking about consuming APIs from business partners or them consuming your APIs or the infrastructure providers you may run on, a software supply chain should integrate that entire experience, that entire delivery model. And with containers as the atomic unit, we have a framework to understand and, frankly, to manage the software supply chain. For simple reasons, right? Containers help us understand who created that piece of software, where it came from, whether or not it was tested, was it scanned for vulnerabilities, what environment was it actually approved for. Okay? And of course, they can be quickly changed, they can be modified, and then redeployed. The end result is that the software supply chain allows you to build software faster, better, cheaper, and go deliver it. Look, Docker and its community, right, what Solomon and team started, Docker and its community have ushered in the era of containers. And we're seeing incredible momentum across it. Whether you're looking at Docker hosts or container pools or the number of jobs around the Docker community, all of it is growing at unbelievable rates, enviable rates. And look, while I'm proud of the accomplishments of the past, I'm far more excited about what's ahead of us. And I want to share some of that with you. Collectively, Docker and its community are defining a comprehensive container platform. That's our objective. In fact, frankly, a lot of that already exists. A platform upon which you can build, manage, and run any application on any infrastructure. That's the goal. A platform upon which you can manage your entire software supply chain. So what are the attributes of that container platform? Well, first and foremost, it needs to support any application. Whether it's traditional or packaged, or it's cloud native, or it's microservices, or it's IoT or edge, it doesn't matter. It's got to support all application environments, whether it's Linux or Windows or mainframe or anything else. Right? That's requirement number one. Number two is it has to give our customers portability and independence. And this is important. Right? Every single customer I've ever spoken to has held this view that what we want is a platform that allows us to run all of our applications on any cloud environment we want, whether it's public cloud or internal. They don't want to be locked in. Everybody remembers the days of building applications on different databases where you are now linked to that application stack. Okay? Our customers also want deployment flexibility. We may choose that we want to deploy this set of applications on a particular cloud. But look, business rules change, requirements change, regulatory environments change. You might want to run those same set of applications on a different cloud in a different time period. You should be able to do that simply with the click of a button. That's what a great container platform should deliver to you. And of course, as we move to a digital world, the role of security has to become front and center at the application layer and frankly, at the data layer. We have to make the entire software supply chain secure by default. It's also got to be an open platform that allows you to plug and play. Right? We've got a huge community of partners, a lot of whom are here today. Our customers ought to be able to plug and play any components that they'd like, whether it's traditional or existing partners that are critical to how they run their business, or it's next generation technologies that are going to be important in the future. We have to be able to deliver a platform that allows you to simply plug and play, and it should work, and it should work reliably. The other piece, and this, in my view, is really an exciting part of our future. We have to deliver serverless anywhere. Right? I want to make sure that what we deliver enables developers to drive incredible productivity, to drive an amazing experience around building products and shipping them faster. Okay? But that serverless has to be anywhere. You can't be linked or tied to one single platform. Right? The same reason why customers want portability. That also applies at the serverless level. And frankly, orchestration. It's an important part of any container platform. But it isn't enough just to make it possible to build and deploy complex systems. Right? The real magic happens when it becomes accessible to everyone. Look, I would tell you, just as Salesforce.com allows you to integrate the manner in which you understand, you market to, you sell to, and you service your customers, Docker is the platform upon which you can build, manage, and run all of your applications on any infrastructure. Right? If every company in the world becomes a software company, it seems reasonable to assume that you need to have a powerful set of tools, a platform, upon which you can manage your software supply chain in the same way that you use Salesforce.com to manage your customer relationships. That's our goal. All right, with that, does that make sense to everybody? Yeah. All right. I'm looking for the non-Docker people. Come on. Look, with that, I'd like to return to where I started, and that's with our customers. If 80 to 85% of the IT budget is already spoken for, and you still have to drive innovation to compete, well, how do you do that? I would tell you it's simple. Modernize your traditional applications. Run them on modern infrastructure. Drive massive cost savings. Take those cost savings and pour them back into innovation. That's the equation. That's the way we think that we can help customers drive into the next century. Go innovate and make sure they have massively competitive solutions. Okay? In my view, it's not often that the technology of the future can also be the technology that supports your past. And that's what Docker is. All too often, the next wave of technology requires not only significant new skill sets and new investments, it oftentimes asks you to throw away your existing investments. And from my point of view, that's simply a non-starter. It's not acceptable. The Docker container platform changes that game fundamentally. Right? The platform, frankly, that millions of developers are using today to build next-gen cloud-native applications or edge computing applications is the same platform upon which you can take your legacy applications and move them to modern infrastructure and manage them in an environment where they're totally integrated with your next-generation applications. And by the way, that can all be done. It has to be done without recoding, without refactoring your applications. That's when it's a platform that adds value. You shouldn't have to choose, right? You shouldn't have to choose to say, look, do I innovate or do I maintain? That's a ridiculous choice. You ought to be able to do both. And that's what Docker enables. In fact, frankly, we're seeing our customers today who are modernizing their legacy apps and using that savings, using that benefit to go drive innovation across the rest of their application suite. So with that, would you like to see a demo? All right. I want to show you this demo of how customers are modernizing the traditional applications. But look, at Docker, I've been told this. At Docker, we have a tradition. And that is that before we do anything, of course, we're going to check the code. We're going to make sure everything's all set up, the internet connection works. We probably even check wind velocity. But there is a higher power that we have to call to. And that is, we have to appease the demo gods. So with that, I'm going to make a sacrificial appeasement to the demo gods and ask that our demos kick off without any hitches. All right, so with that, here's what I'd like to do. I want to invite two of Docker's finest up to the stage, Christy Howard and Ben Benefoy. Okay? And they're going to show you how we're going to modernize a traditional application. Christy, Ben?
Oh, hey, I've seen you around the office, but I didn't catch your name. Are you new here? I'm Ben.
Hey, Ben. I'm Christy. I'm not actually an employee here. I'm with a Docker partner helping your company modernize their traditional apps. So what's your role here?
I maintain our e-commerce offering. Essentially, it's a lot of traditional apps that just no one wants to touch.
Oh, well, you know what they say. Legacy apps need love, too. In fact, I'm actually free for the next 5 minutes if you wanted some help modernizing one of those apps.
5 minutes. I do have this app that's kind of a pain to maintain. We could modernize it. It's our pet store app. It runs Java Spring on top of Tomcat. I think it was written 9 years ago.
Sounds like we found our target then. So let's get started. Can you tell me where the app is hosted?
Yeah, it's an old box in a closet somewhere. Usually when the app crashes, we flip a switch and the server restarts.
Ooh, well, Docker can definitely help you out there by automatically restarting the server when your app crashes.
What? Our productivity is going to go through the roof.
That's for sure. So can you log into the instance where the app is running?
Ha, funny story. I once accidentally, of course, wiped our production database. Since then, my production privileges were kind of removed. But I do have access to 9 years' worth of backups.
Okay, good. We can actually use those backups with the Docker application converter to containerize your pet store.
Wait, the Docker application converter? Whoa, whoa, whoa. We can't modify this app.
Oh, don't worry. The Docker Application Converter, or the DAC, as I like to call it, doesn't actually modify your source code. It's going to scan your virtual machine backup, extract the bits it needs, and then automatically generate a Docker file that you can use to build the application image.
What? That's awesome. All right, let's get started. So as you can see, I have plenty of backups here. Let me grab the backup from last night.
So I worked with all of your admins to make sure that the DAC tool was preloaded on all of your workstations.
So DAC help. Yep, it's installed.
Great. Now you can run DAC discover tar with that backup that you have there.
DAC discover tar.
Yep.
Okay. Do I want to Dockerize this application? Well, yes, I do. And what application? I'm just going to do them all. Okay, looks like it's done.
Great. So the DAC tool created a folder that you can CD into, and you can look at your new Docker file.
Doc application, Tomcat, JPET store. Oh, wow. It's like magic. Let's see what's in the Docker file. Yep, it looks like it's using Tomcat as my base image. It's copying the JPET store war over, and it's exposing the right ports. Looks good to me.
Yep. All we have to do now is actually build the image using this Docker file.
Docker image build. And it's done. Man, no one's going to believe that I've Dockerized the pet store app. I can't hardly contain myself. I'm so excited.
Let's make sure and deploy this on-prem before we're all done.
Right. First, let me push it to our on-prem registry. Image push on-prem. OK.
Now for the moment of truth.
Source my DCEU. And run it on port. So I'm mapping port 80 to the port 8080 that we saw in the Docker file and using our on-prem target. OK. Looks like the container is coming up. Let me see the website. On-prem. And boom, there it is.
Wow. What a colorful pet store. I mean, congratulations, Ben. You just brought an app from 2008 to 2017 in a few minutes.
Wait. Before you go, I should probably write these steps down so that I can repeat it for our other legacy apps. So we started with an instance backup.
Yep, and then we used the Docker Application Converter to give us a Docker file.
Right, which we then used to build and push our image to our Docker trusted registry, and finally deployed it on-prem. Was that it?
That's it. Well, my work here is done. Good luck modernizing your other apps.
Thank you. Thanks. So, what do you think? That was simple enough that even I could do that. Look, understanding the power of a container platform is great. Seeing it done is even better. Right? But in the end, what's most impactful and what's most credible is hearing from our customers, the people that are facing the same business problems you and I are facing. Okay? So, by the way, each of the companies that are listed here, right, these are Docker customers that are driving next generation applications or MTA, modernizing traditional applications. And they're all here today, or during this week. I'd love it if you stopped by and saw them. You're going to hear incredible stories. You're going to hear about great experiences, both good and bad, by the way. Right? You're going to hear about their experiences, a lot to learn from them. Now, look, I want to invite a member of the broader Docker family to the stage. This is Jeff Moore, who's the Director of Engineering at MetLife, a fantastic customer who's actually done multiple things with us, not just creating next-generation applications, but also moving their existing legacy applications to modern infrastructure. Please join me in welcoming Jeff to the stage. Jeff?
The guy's hat fell off. All right, well, that's my appeasement to the demo gods right there. Hey, everybody. Thank you, Steve. Good morning, everyone. How are we doing? Yeah, I know. This is my second DockerCon, and I love these things. It's just a great experience to be here. So I'm Jeff Murr. I'm responsible for container and open source platforms at MetLife. So kind of give you some idea about MetLife, some background. MetLife, we're in the information management business. Information about our 100 million customers and the data around all of their different insurance policies. Each of these policies to us are promises. Promises we keep and make with our policyholders. Some of them literally are built for a lifetime. We maintain these promises in almost every corner of the world. We're nearly a 150-year-old company now, and with that comes infrastructure, history and legacy infrastructure that allows us and keeps us keeping those promises around the globe. So why am I here? All right. So in April of this year, my colleague Aaron Aids presented at DockerCon about MetLife's first project with Docker. Our Docker captain, Tim Tyler, he talked about the transformation internally required to make this happen. Essentially, we got together with some developers, an engineer, an architect, and we put them together. We called them the Mod Squad. And they quickly figured out how to do this new thing of microservices to make it a reality. What they learned was how to take an application critical to the digital strategy of MetLife to production, leveraging Docker very quickly. We learned innovating at MetLife was hard because specifically we have systems and applications with different operating models and different knowledge bases, different standard procedures across 5 different deployment models around the globe. But we did it. We did it with some success that prompted MetLife to kind of rethink what else could be happening, what else is next. Now, take a step back with me just a second further. In a highly regulated industry like insurance, we've become a highly risk-averse, high-control IT organization. So this word, disruption, isn't always viewed in the same light as, say, I don't know, some technology geeks and nerds at DockerCon. I say that because I'm one of those. I'm here, right? I'm in the room. But for a second, think about leaders inside of the enterprise IT organization. Disruption comes with cost, with risk, impact. It's considered a rough word to kind of deal with. Normally, adding new tech just increases cost and overhead to an already complex ecosystem and adding more maintenance and currency line items to a budget. So, you did this incredible project for our digital strategy. What else? What are you going to do now with containers? So, now what? There we go. All right. Well, Docker came to us with Avanade and Microsoft and the modernized traditional application POC program. They offered to help us containerize some of our existing applications with this program. So I want to share with you our experience and some exciting results that are really compelling. So first, the POC project happened. First thing we did was we selected a Linux-based application built in Java. This is our do not call application. It's essentially a solicitation management capability used by our sales staff. It's not an exciting application. It's not about the app. But what it actually helps us do is comply with privacy and opt-out regulations. Put a phone number in, check some data sets, comes back, you can call them, you shouldn't call them. It took us 1 day to containerize it. We budgeted a week because, we got to be safe. But we blew everyone away. We came down after the first day and said, it's up, it's running, go test it, it's out there. That wasn't the story. That's not what it's about either. We also did it with very little administrative overhead. 3 workers, 3 masters, put it out, deploy, run. Again, not the story. We did it with 0 changes to the code. That was just amazing, right? But again, not the real impact of the story. The idea now, though, is that what we were able to do, we took one technology stack and we converted it. We built a model. Now let's think about applying this to other applications and how that impact might really resonate. So what we found were 600 applications, and we did some capacity modeling. We found we could reduce thousands of VMs to hundreds, tens of thousands of cores to just thousands, and we can take what was historically a 7% utilization against costly infrastructure, turn that up to 70% utilization, and maximize our infrastructure investment. These data points built a business case using what we saw with this POC that was compelling for our leadership and understood now we can justify a 66% target reduction in costs. For MetLife, that translates to tens of millions of potential run rate reductions. That's real dollars saved, not avoided at a project level. I keep doing this sales pitch and say, but wait, there's more. There is. The idea was, this again is just the US infrastructure, and it's only 10% of our total application portfolio. So just imagine the possibilities. We have now a repeatable model in which this application stack and the application teams that depend on it, we can use to modernize them and put them into containers. There's also this ability, MTA is now internalized within our staff. So not just this app, but now we can start doing the same thing for the next technology stack, and we'll be able to then target another application, whether it's running on Linux or Windows. The do not call app, again, was not exciting. It's now become exciting. So, as we have gone down this path with Docker, first with the new project, the digital strategy, lifting us into microservices, now with this ROI story, this MTA, looking at our legacy infrastructure and talking about modernization, we see some patterns for success, and I want to share those with you because I think that's the thing that could probably help other companies, and I feel really strongly about some of these. So what's important to remember, start small. It'll grow naturally, so don't bite off more than we can chew. In a reality sense, that's probably a simple application. But assess that application using the fact that it will build a repeatable model to help you really guide yourself into this adoption. Now, create a strategy team. By that, what we found was best is that that strategy team creates a model. Doesn't implement the model, but creates that model and builds in a kind of integration to the fabric of the current people and process. So then you have that strategy team giving it over to the existing people and incrementally change over time the existing people and processes into this. And we're in Denmark, I can say this. A rising tide would rise all boats to get into line with this new strategy. This enables now a decentralized, less risky, less costly innovation pipeline. Everyone's on the same page eventually. We're talking containers now. Everyone gets the fact that it's not about this other team. It's about everyone behind a strategy, and it's going to take some time, but pragmatically we'll get there. So it's really about taking this thing that's disruption, but it's less disruptive as a whole because it's going to be done in parts. So this high-control IT organization is able to realize the extreme value behind something that is containers. And this is the MetLife platform where Docker EE is the backbone of our globally engineered container ecosystem. It's a supply chain. Different types of applications can enter that supply chain consistently the same way. Doesn't matter if they're microservices with the latest technology, traditional applications from years ago that we're maintaining going forward, vendor packaged containers or third-party applications. And this is exciting, just for a second, to kind of bring it around to an infrastructure point of view, if there's any infrastructure engineers here. Keep in mind, vendors offering us containers is fundamentally different than the past, right? We get on the phone with these vendors with their new software applications, and normally it would be we're going over machine specifications, size and scope, software prerequisites, and then installation guides and standard operating procedures. It just starts going down. Well, now it's one model. You've given us the container, we'll ship and run it. And then the policy-driven promotion. So we get into the run state. Sorry, let's go back. The ship state, everything is signed, including those vendor ones, scanned, integrated. It feels like just natural code. Software delivery, lifecycle management for infrastructure and containers, all in one place. And then finally, the run state. We get to a policy-driven promotion deployment with Docker to our technologies, our applications, to run anywhere in the world. Now, to me, Docker EE really is creating opportunities for MetLife. Docker EE Enterprise Edition is a self-funding disruption to innovate to scale without blowing our budget. It's helping us attack that 80% of budget allocated to that maintenance and enabling us to then allocate it over to innovation in a very, very consistent way without disruption to business. And personally, for me, this job at MetLife did not exist before. It has created an opportunity for me and my team to build a new platform at MetLife, one that will play a key part of our transformation and deliver on our digital strategy. Thanks a lot, guys, and have a great, great conference.
Thank you. Jeff, I want to thank you for sharing this experience with all of us.
Yeah.
It's really been great to partner with you and the MetLife team.
Absolutely.
And I really want to thank you for all of the capabilities you've been able to show here and the impact that it's had to MetLife. In addition, on behalf of the product team, I'd really like to thank you for your partnership with us in making Docker EE a better platform for not only you and the MetLife team, but for all of the Docker audience and all of the community out there.
Great, thank you.
Thank you
a lot.
very much.
Thanks a lot, guys. Good conference, all right?
So Jeff and his coworker Tim are going to be here throughout the week. They're going to be presenting more about their experience at MetLife. They've got 2 additional sessions today where they're going to talk through the specifics of the architecture, the business case, the organizational changes, and the applications that they used and the experience they had at MetLife. So I encourage all of you to please check those out. Now with that, I'd like to shift your attention back to our consultant, Christy, and Ben, the developer. Now, if you recall, they just recently showed you how to modernize a traditional application. They were able to take an existing enterprise application, containerize it, and deploy it. Let's take a look at what Ben's been up to since, shall we?
You've got voicemail.
Hey Ben, good job on modernizing the pet store. It's been a huge success. Now, I'm going to need you to set up our new German partner with a custom version of the app in the cloud. They want to go live tomorrow, so please get it up and running in their staging environment ASAP. Check your email for further instructions. Thanks.
Okay, I got this. I can do it. The cloud, tomorrow.
Hey, Ben, what's up?
Oh, good, you came here to help, right? So ever since we modernized, our pet store has been super popular, and it's been deployed globally to all of our data centers.
I'm so happy to hear that. Sounds like a really successful Dockerization.
Well, yes and no. We now have a German partner who's asking for a custom version of the pet store, featuring, guess what? German Shepherds.
And the problem is you're a cat person?
No, I love German Shepherds. The problem is selling them within Germany, and because of some regulation or whatever, we have to deploy in Germany, and it has to go to production tomorrow.
You must be referring to the BSI Cloud Computing Compliance Controls Catalog.
That's what C5 stands for.
Yep, 114 requirements that set a standard for secure cloud computing and increased transparency in data processing.
Listen, I'm all about complying to security standards, but we don't own ORN Infra in Germany. The closest thing I have is a cloud staging environment in Frankfurt, but our app is not a cloud application. And above all, ich spreche kein Deutsch.
Don't worry, Ben. Docker makes it really easy to move your app from on-prem to the cloud. The first thing you can do is push the custom version of the German pet store to your partner's registry in Frankfurt.
Okay, I can do this. So I've already logged into our partner's Docker Trusted registry. So I'll go ahead and push the image. Push, DTR. Okay, all the layers are uploading, and we're done. What's next?
Great. Now we need to update the compose file that we're using to deploy on-prem so that it uses this new image you just pushed to your partner's registry in Germany.
Okay, well, here's the existing compose file. I'm going to update the tag to be the 2.0 Germany and make it point to the DTR staging. Is that it?
Not quite. BSIC-5 regulations require that all application passwords are stored encrypted.
Way ahead of you on that one. I'm already encrypting all the passwords using Docker secrets. See? Docker really does make it easy.
Oh, but what about network encryption?
What about it?
BSIC-5 regulations require that all network traffic is encrypted.
Well, that's it. We're out of luck. Because if there's one thing I'm not, is a network engineer. I have no clue how to encrypt our network here, let alone in Germany, in the cloud.
Well, I'm not a network engineer either, but it only takes a small change to the compose file to encrypt the network. Can I show you?
Please.
So if you scroll down to where your networks are defined in your compose file, all you have to do is add encrypted true and save it. Maybe I am a network engineer after all.
Christy, back to our app?
Yeah.
Okay. Well, first, let me source our partner's Docker EE bundle. This way, my Docker client is now targeting our partner's Docker EE staging environment. Should I try to deploy it?
Ship it.
Docker stack deployed. And done. Man, my boss is going to be blown away when he hears about this.
Wait, let me make sure everything looks good in the Docker EE dashboard.
Sure, let me pull it up for you.
All right, so good. I can see that the services are up and running. And if I look and scroll down, I see that you're using the secrets you defined.
Right.
And if I go to networks, I can see that we're using encrypted communications. Nice work, Ben. I think we're all done here.
Wait, we took our existing on-prem app to the cloud with Docker that easily?
Yeah. All we had to do was update our compose file to use the new image you pushed to your partner's registry, to encrypt the network, and to use Docker secrets.
Right. And finally push it to Docker EE, just in time for me to get an espresso before my next meeting.
Oh, can I see what the app looks like?
Ah, right. So going back to services, web, endpoint, and to store, and voila, German Shepherds galore.
Wow. No offense to those parrots, but those German Shepherds are pretty good looking.
I didn't get to do this last time, so I'm going to do this now. Great job, Ben and Christy. Let's give them another hand. So as you saw from their demonstration, they were able to take an existing traditional application, an enterprise application, and they were able to do 3 quick things to it. After they containerized it, they were able to first make changes to it. So they were able to turn it from a parrot pet store to a German Shepherd pet store. They were able to move it to the cloud. So this is an existing application, not built for cloud, that they were able to containerize and now move into cloud infrastructure. And third, they were able to add existing security controls to this application. These existing security controls allowed them to encrypt the network and apply secrets to their application by changing just 2 lines in their compose file. So pretty powerful stuff. This set of capabilities is available to every enterprise application. The moment you containerize it, you have at your disposal all of the features and the values of the Docker platform. This is some of the most amazing and impactful things you can do to an enterprise application. But I want to tell you some more. There are additional values that the Docker platform can bring to every application, your enterprise applications, your microservices, your third-party applications. Image management, the ability to move your application through the software supply chain and make sure that the right people have access to it at the right times. Policy automation, by having the software supply chain fully mapped out, you can also add control gates. Gates that allow you to control how and when the application proceeds through the stages of that software supply chain. End-to-end security, the ability to add additional security controls around the application without having to change it. And finally, multi-tenancy. Now that you've got your applications containerized, you can also take those applications, co-locate them on a single cluster, apply resource controls and access controls to ensure, again, the right people have access to those applications in their running state, and that they have the appropriate service levels. Let's talk about each of these in turn. So with image management, we're able to ensure that every application, as it goes through the Docker Trusted Registry, has the appropriate authorization controls around it. That means that the right people get access to those images at the appropriate times through the software delivery process. We can ensure that distribution of that image happens automatically. So developers who need access immediately, or operations teams who need to access that application to deploy it, have access across geographic zones and availability zones. We can ensure expiration of old images through the registry. So as images become stale or expired, and you don't want them using up your storage space, because storage is expensive, we can ensure that we clean up after ourselves. And those old CI jobs, those old images, just get removed off of disk. And then finally, you have integration points. So you don't have to retool your entire continuous integration toolchain to enable this. You can actually tie this in with what you already have. Any automation scripts you have existing, any CI tooling you may already be using. Now couple this with policy automation. Policy automation allows you to establish the control gates by which an individual application and the container image, as it goes through the software supply chain, is controlled whether it proceeds to the next stage or not. And those controls can be done at the level of size of the image. They can be done by the number of vulnerabilities an image may have as it proceeds through that chain. Hopefully none, but sometimes there are. And it can be done based on what's in that image. So specific binaries that may be located in that image or not. Now, these policies allow you to enforce in an automated way the ability to move your application through that supply chain. So Docker Trusted Registry provides all of those enforcement points that you can customize per your company's guidelines. Now, at the very end of the supply chain, you can also additionally assign policies around either isolation. If this image is not supposed to be deployed to production, we can put it off into its own private repository where it may need to be addressed, or archival. We can put it into a repository where it's now accessible for long periods of time and no one can update it, change it, or modify it. And we know in many industries where you have strong compliance regulations, this is important. 7 years from today, when the developers are all long gone, when the operations people who had been running that app no longer remember what it is, that app still needs to be available. Now with end-to-end security, we can apply additional controls around every application. These are the 3 S's, as we like to call them inside Docker: signing, scanning, secrets. With signing, you provide integrity and authenticity of that application as it goes through the software supply chain. You know who it came from, and you know if it's been modified. And if it has been modified, you know who modified it, and you can roll back from that change. So with signing, you can assure yourself that you knew the application came from your own development teams, from the Docker store, or from an outside party. With scanning, you get greater visibility into the image. You can see what's going on inside that image. You see every binary, statically linked or dynamic. And that means you can also establish the vulnerability of each of those binaries, so you can determine whether you've got binaries that have vulnerabilities around them. And with vulnerabilities coming out every day, it's important to be able to know that state at any given moment. You can also look at the copyright state of all of those binaries, as well as just the existence of those binaries. And lastly, secrets. You know, in typical deployments, and we see this a lot in enterprises, you either have specific secrets that developers have to encode as a part of their source code, and they check it in, or you have operations teams that put those secrets as environment variables when they run the application. There's a problem with this, right? We all know this. This is not how separation of duties is supposed to happen. So with secrets, we can assure that the right people have access to the specific enabling capabilities to allow a container to touch another container or another service. By ensuring that secrets are mounted into the container and only accessible to the container, no longer do you have to check it into source code, nor do you have to make it available as a part of the environment for the running application. They can be managed completely independently, allowing separation of duties. Next, enterprise multi-tenancy. Now, as you take each of your applications and you further consolidate them, remove all of the unnecessary OS dependencies that are in the application, you now have smaller and smaller images that you can deploy. As you take those images, you're able to co-locate them on your cluster. Well, you want to make sure of two things. The right people have access to those containers when they run, and that the service levels for those applications are maintained. That's every operator's first rule, first tenets. So with our role-based access control system, you can assure yourself that the right teams have the right access to the right containers, to the right applications. You can do it all the way down to the individual nodes of the cluster, including the networks, the storage, and the individual containers and secrets associated with that application. That level of granular privileges allow you to control who gets access to what. And then, with resource constraints, you can ensure that the service levels are maintained for each of these applications. All of these features together create a really powerful impact for any enterprise application and allows you to further consolidate into your single cluster and allows you to add value as those applications become containerized. So what we've talked about to date from this morning until now is really just the start of your modernization's journey. We've been talking about modernization as kind of a step one. And what we want to do is continue this conversation throughout the breakout sessions and tomorrow. So tomorrow we'll spend a lot more time to walk you through specifically how you're going to modernize your applications and run that all the way through to production in a running environment. Thank you.
Hey, brother, thank you.
Thank you.
I don't need it. So, everything that Docker is today, and everything that we hope it will be in the future, right, is based upon, frankly, a vision or a concept from a pretty incredible guy. He was always focused on delivering an incredible developer experience, and using his words, he wanted to build tools of mass innovation. Right? What started off as a simple concept of containers, right, which we certainly didn't invent, but we certainly democratized. What started off as a simple concept of containers is moving to a platform upon which all of us can innovate and drive value. It's the platform upon which every company becomes a software company. Would you please join me in welcoming Solomon Hykes to the stage? Solomon's got some great news to share with you.
That looks okay. Okay, hey everyone. How's everyone doing? So I'm here to talk to you about modernizing enterprise apps. No, I'm just kidding. I think you got the message. So, no, I want to talk a little bit about the future, what we're building next. And before I do that, I want to talk just a little bit about Docker today. So this is my little Docker in a nutshell. Right? It sits on the infrastructure below. It runs your applications above. It's a container platform. Right? It gives you that neat independence layer so you can have your developers and operators use the same interface, the same workflow from development to production, the whole supply chain. Right? And that gives you some
great benefits that you just heard about. And over time, of course, we keep working to make that the ideal platform, right? We always want to improve. And to do that, we follow a few principles. And the first principle is what I call independence. Basically, Docker should never lock you into anything, right? Whatever the next infrastructure you want to choose, no matter what the next pattern or technology you want to use for applications, Docker should will never hold you back from that. It will always enable that choice, which means you stay in control of your technology roadmap, and that's crucial. That's principle number one. Number two is openness. Everything about Docker is built around open interfaces, open source components, an architecture that is as modular and pluggable as possible, so that regardless of what your system looks like, your storage, your networking, your monitoring, etc., you can always fit Docker in because you can swap components in and out, right? Docker adapts to you, and that's because it's open. And the third principle is simplicity. Docker has to be simple. It started out simple, and we work really hard to keep it that way. And there's a common misconception about simplicity, I think, in this industry. We tend to underestimate it. We tend to think that the more complex something is, the more powerful it is. In fact, we think it's the opposite. We think the most powerful systems are really simple. And that's because they have to be simple to be robust enough, resilient enough in even the most critical environments. So these are the principles that we follow every day. And with these principles in mind, now I want to talk a little bit about the internals, what's under the hood. So I'll keep it really simple. You can think of the Docker platform as a stack with a few layers, right? And the first layer at the bottom is the container runtime. Now, the container runtime is where the container magic happens, right? It's where it all started. It's where the roots of Docker are. And it's what lets you package up every piece of your application to these repeatable, standardized units that you can do all these magical things with, containers. And over the last few years, there's been a lot of iteration at that layer. But this year, finally, we're in a place where we have a stable set of open standards with the OCI, and we have an industry-standard open implementation called Containerd. And Containerd is by far the most widely adopted container runtime. It's running in hundreds of millions of nodes today around the world. It's rock solid. It's being developed as a consortium of open contributors, some of the largest technology companies in the world, all building it. And it's the very foundation of the Docker platform. Now, on top of a container runtime, you need orchestration. And orchestration is what ties all of your individual machines together, each with their own container runtime, into a single distributed system. And it's what allows you to deploy your application not on one machine at a time, but across that whole system. It's what makes your application distributed. And to take advantage of these layers, as a developer, you need tools. You need an environment that lets you build, develop, deploy, package in a way that takes advantage of containers, that takes advantage of orchestration. And we deliver that with what we call Docker CE, the Community Edition. And that's where you find the familiar workflow, the familiar tools like the Docker command line, Docker Compose, Docker Build, Docker Push, Pull, all of that good stuff. So that's Docker CE. Now, when you want to go to production, you want to manage your applications, you want to secure them, you want to scale them, you want to monitor them, all of that, we provide a set of management services, and we call them Docker EE, the Enterprise Edition. And if you look at these 4 layers, that's really Docker in a nutshell. That's a complete container platform, and it's our blueprint for developing it and improving it over time. Now, as we develop it, as we develop that platform, we have a really simple model for improvement. And it's got 3 really simple steps. Step 1, we listen to users. There's millions of people using Docker every day, developers, operators. And as they use Docker, as you use Docker, you tell us about it, and we listen. And as we listen, step 2, we improve the platform. One detail at a time. We fix bugs. We add features. We implement new use cases that you tell us about. And step 3, we repeat. And by the way, if you're wondering what life looks like at Docker, that's basically it. We listen, we improve, and we repeat. And that's all we do. And in the process, we see patterns, right? We see areas that users care a lot about. And there's one pattern we hear a lot about these days, and it has to do with orchestration. Specifically, it has to do with the fact that not everyone uses Swarm. So Swarm, you remember the orchestration layer. Swarm is Docker's built-in orchestrator. And when we set out to build it, we wanted orchestration to be completely seamlessly integrated. We wanted our users to just forget it's even there, right? You install Docker, there's orchestration. It's secure out of the box, it scales out of the box, it works with all the usual tools. And to achieve that level of integration, we built a custom orchestrator. And we open sourced it, it's called Swarm. The problem with that is now you have restricted choice. If you want to take advantage of that full user experience, you have to adopt Swarm. And if you do, you get that whole set of benefits. But if you don't, if you have another favorite orchestrator, of which there's many out there, it's a large open ecosystem, then now you have a dilemma, because you cannot bring that other orchestrator into the Docker platform with the same level of integration. You don't get the same seamless experience. And that dilemma gets even worse for large organizations, because in a large organization, you have many teams, and different teams will typically use different orchestrators in their respective projects, and now you have silos, and you lose the benefit of one open, independent platform that can follow you anywhere. So that's a dilemma that's been on our mind for a while. We've been trying to fix it, and we've made a really big step towards fixing it, and I'm really happy to announce that the next version of Docker will support 2 orchestrators out of the box natively, Swarm and Kubernetes. Surprise. Okay, so this is what the stack looks like now. It's the same 4 layers, except now you have 2 orchestrators integrated at the same level with the same user experience, all the same bar of quality that we set with Swarm, right? And that gives you the best of all worlds. So you get the best enterprise management services out there with Docker EE. You get all the developer tools that are widely adopted around the world, the same Docker CE experience. It's all running on the same industry standard container runtime. That means any OCI compliant system anywhere can run this stack. And now you get these 2 orchestrators integrated in. And this is the important part. This is the real thing. It's not a fork. It's not a wrapper. It's not a half integration shim thing. This is real Kubernetes sitting next to real Swarm. It's a 100% upstream, compliant, vanilla Kubernetes that you get when you deploy the Docker platform. So when we looked around at available orchestrators and we set out to build this, Kubernetes stood out pretty quickly. First, because it's a really popular project. It's got a lot of users. And they all use Docker too. So it's a great way to solve that dilemma for a lot of you all at the same time. And second, because the Kubernetes community has a really strong connection to the Docker community. And that's because of our shared history. If you look back, Kubernetes came about within the Docker community as an effort to extend and improve Docker. And because of that history, if you look at these 2 communities, it's a lot of the same people. We go to the same meetups, we use the same tools, we argue about the same stuff. We follow the same engineering principles. We use the same language. It's really like one big family. And like every family, we argue, and that's okay. But at the end of the day, it's one group of people trying to solve the same problems. And so with such a great integration of people, it just made sense to have a really nice integration of code also. And so that's what we've done. And to talk about that connection between our communities and our shared history, I'm very happy now to invite a guest on stage. He's a great friend of Docker, and he's been a great supporter of this effort. Please welcome on stage co-founder of the Kubernetes project, Brendan Burns from Microsoft.
I don't have any demos, but I guess I get to put my sacrifice up there anyway. I'm really thrilled to be here, and I'm really excited to welcome Docker and Solomon to the Kubernetes community. But in fact, actually, but really, Docker has been here since the beginning, right? I think that it's really important to note, and Solomon made a really good point, we've been going to the same meetups. We've been talking to each other for a very long time. In fact, I remember nearly 4 years ago, I was sharing demos with Solomon of this thing I was calling Project 7, back before it even really had a name. And we'd been using the Docker tooling for even longer than that. And then eventually, the idea of Kubernetes and the open source project itself really crystallized for me coming out of the inaugural Docker meetup in Seattle in November of 2013. And so we've really been co-evolving a lot of the same ideas together, and it's really a thrill to be here today. In addition to the partnership that we've had in the open source communities, I think it's really valuable to mention the strength of the partnership between Microsoft and Docker. And you saw some evidence of this earlier with our shared customer, MetLife, who's been able to use the modernization of traditional applications program to take some of their applications, transform them into containers, bring them to the cloud with Azure, and radically change both how much it costs to run those applications, as well as the speed and agility with which they can change and modify those applications. It's an exciting thing that we're bringing to all sorts of enterprise customers throughout the software industry. But I think it's really important as well at this point, given all of this shared history in the open source community, in the business side of it as well, I really want to say thank you to Solomon, to the Docker team, and to the broader Docker community. It's not an exaggeration to say that Kubernetes would not exist without the container revolution, that the focus on taking developers, meeting them where they are, and empowering them to develop more and build better applications faster brought about in cloud today. And so I really want to say thank you to all of you, to Solomon and everybody else. It's been a great experience so far, and I'm looking forward to even more. The focus on developers and empowering developers is another thing that I'm really excited about in this partnership. Microsoft has a rich tradition of doing this, has done it over time repeatedly, from products like Excel that took accountants from being spreadsheet users to being programmers, to technology like Access, Visual Basic, that took hobbyist programmers and turned them into application developers. And I think we're seeing this in the open source world of the cloud. You saw earlier demos on a Mac with Visual Studio Code. We're open sourcing things like the .NET runtime. There's a real engagement with this new way of building software out on the cloud, and I'm really excited that we can bring that technology together and partner. But it's not really just about the open source projects that Microsoft has been putting out there, but it's also about participating in these broader communities. We have leadership people on the steering committee of the Kubernetes community. We have people in the leadership on the Open Container Initiative, the Cloud Native community, the Cloud Native Compute Foundation. And I really want to do a special shout out to John Howard, who is Microsoft's #4 contributor, he is from Microsoft, and the #4 contributor to the Moby project. We're really proud of all of the various contributions that we've been able to make across the world of open source. And so, thank you. It may seem like containers have been here for a long time, and for some of us who have been here since the very beginning, it really has been quite a ride. But I want to finish by saying I profoundly believe this is really just the beginning. We're just starting to put the boring pieces into place that make the technology that we can build on top of it possible. It's still too hard to build distributed systems. It's still too hard for developers to come together and quickly, rapidly, and reliably build scalable applications. And so I'm incredibly excited to continue to work with the Docker community, with the broader open source community, to develop the technologies that will build on top of the things that we're talking about today, to empower not just the developers who are here, but the developers who are still learning about containers and still learning about what it can do for them. Thank you very much, and enjoy the conference.
All right, thanks again, Brendan, for the kind words and for coming to visit us. So you saw the diagram, and Brendan told you about how our communities have been working together. Now, if that's okay with you, let's get down to business and talk about how to use this thing. Yeah? All right. So let's talk about development first. If you're a developer and you're using Docker, your workflow looks a little bit like this. You've got Docker for Mac or Docker for Windows or the Docker CE command line tools on your workstation. And you're using Docker build, Docker compose, you got your tight development loop, and then if your production is in Swarm, then you also can test locally on Swarm right there because there's a Swarm built in. But if your production's on Kubernetes, then things get a little more complicated. You gotta get Kubernetes to work on your workstation, you gotta translate files back and forth between compose, Kubernetes, you gotta negotiate that set of tools and the workflow with your ops team. So it's possible, there's tools out there to do it, but it's just not as smooth as install Docker, go. And we're fixing that. So in the next version of Docker CE, you get the same tools, the same local Swarm for testing, and you get a full-blown upstream vanilla Kubernetes distribution built in. And you can develop on that with the same Docker tool. So you don't have to learn any new Kubernetes tools if you don't want to. You can just keep developing, and it just works. But if you do want to use the Kubernetes tools, then the new Docker CE is also a pretty sweet distribution of Kubernetes on the desktop that's guaranteed to just work with the usual level of quality and finish of Docker. So you get the best of all worlds. So at this point, I suggest that we look at this live. You want to see a first demo of Docker and Kubernetes together? All right. So to demonstrate developing for Docker and Kubernetes, please welcome on stage David Gageot.
Hello. So I'm David. I'm a developer. And I'm working on an application that's going to be deployed on Kubernetes. And I'm using Docker for Desktop. It is available both on Mac and Windows, and it is the easiest way to develop for the Docker platform. So let me show you my application. It's a very simple application that is called the Words app. It'll show you random sentences, and the more you scale it, the funnier it gets. It's all described in the Docker compose file. See? It's an application made up of 3 services. There is a web front end. There is a Java REST API with 5 replicas. There is a SQL database. Very simple, straight to the point. It's compose as usual, and developers, they do love compose, right? So, OK, I've got my application defined. Now I want to run it. Let me show you my usual workflow to deploy such an application on Swarm. On Swarm, I would usually start by building the application with Docker Compose. Build. I need to learn to type also. Yeah. Docker Compose build. It will build all the services. And when it's done, I usually deploy it with Docker Stack Deploy. See? It's going to take all the services from my application. It's going to run them. And then it's going to monitor. Oh. It's going to monitor the state for the application. And when they are up and running, my application is ready to be accessed. I can see the logs. I can connect to it. We just have to wait for a couple of seconds. Did somebody touch my machine? No. Yeah. They're laughing behind, yeah? So I can list my stacks. I've got a stack running with 3 services, and I can have more details. OK, so I can see my database. I can see the front end. I can see the Java that is scaled to 5 replicas. I can also see the logs. So it's giving me a merged stream of all the logs from all the services. And because I'm using Docker for Mac, it is very easy to connect to that application. I just have to open localhost on port 80, and I should have my application. Let's try that. Yeah, it works. Let's try a new one. So what it does is every Java REST API service serves a random word, and the more I scale it, the more randomness I've got. So I've got more random sentences. Okay, so this was my usual workflow to deploy on Swarm, right? I built the application, I deployed it with Docker Stack Deploy, it's up and running, and now what I have to do is deploy it on Kubernetes. But I don't really know where to get started, right? You would expect that I install a whole new toolchain to do that. But here's the secret that I have to tell you. I installed the latest version of Docker for Mac, Docker for Windows. It's a preview version. It comes with both Swarm and Kubernetes running on my laptop. How cool is that? You know the best part? The application I deployed in front of you using the Docker CLI, it was not deployed on Swarm. It was deployed on Kubernetes already. Let me repeat that for you. It's already running on Kubernetes. I don't have to learn anything else. Let me prove that, OK? So now, Docker for Mac comes with a single node cluster that I can use for development. It is based on LinuxKit. And I can just target my Docker CLI to that cluster, and I will deploy my Compose-based applications. We extended Kubernetes with API aggregation so that it recognizes the Compose file and converts it on the fly to Kubernetes native resources. Let me show that. See? It took my Compose file, analyzed it, and converted it into pods. I can see the 5 pods for the word REST API. It converted it into services, deployment, replica set, all of this automatically. And we've also added the type stacks as a first-class citizen to Kubernetes. Yeah. Still have to learn to type. Get stacks. Yeah. So even with the Kubernetes CLI, I can see my stacks. This supports deployment, update, rollback, logs, scaling, everything you'd expect from the Docker CLI. It's cool, right? I think it's difficult to make it easier. So just to sum up, I showed you that you can use a single toolchain to deploy either on Swarm or Kubernetes, Docker for Desktop, Docker Compose, the Docker CLI. I hope you enjoy it, and please don't forget to sign up for the beta today. Thank you.
So that was pretty cool. OK, so we saw development. And you've seen how the same Docker tooling can work on both Swarm or Kubernetes, right? So developers don't have to learn anything new if they don't want to, but you get the real Kubernetes right there if you do want to hit it directly. So it's a real two-way integration. Now let's talk about production. So here's what you get with the next version of Docker EE. First, you get a full enterprise-compliant distribution of Kubernetes ready for production, sitting right next to the same usual production-ready distribution of Swarm. So you get both orchestrators ready to go. And on top of that, you get the full suite of management services from Docker EE, set up to manage both Kubernetes and Swarm in one place. So you get all of the node lifecycle and cluster lifecycle features. So you get cryptographic node identity for every node. You can automatically provision and update clusters, all of that for Kubernetes and Swarm. You get the full suite of supply chain services. You get the trusted registry, image scanning, cryptographic verification of images. You can set up promotion policies and the whole pipeline for deployments exactly the way you like it and feed it straight into your Kubernetes and Swarm clusters. You get all the multi-tenancy features, user management, role-based access control, LDAP integration, the node-per-node isolation, so certain apps can be restricted to certain parts of the cluster, all of that good stuff for Kubernetes and for Swarm. You can manage all of that with the same UCP dashboard, so you don't have to send your teams running back and forth between the Swarm silo and the Kubernetes silo. You can manage everything from one place. And the whole stack, from Containerd to the Kubernetes distribution, Swarm, and all the management services, the whole thing is supported and certified end-to-end for all major commercial operating systems, Windows Server, Red Hat, SUSE, and all the major Linux distributions. So you'll never be locked into a single operating system. Pretty cool. So now I suggest we see that in action. You ready for a second demo? All right. So to demonstrate Kubernetes and Swarm together in production with Docker EE, please welcome on stage Daniel Hilgens and Alex Mavroyanis.
Okay, so Alex, I need to deploy that Words app into production. Now, I've been using Docker Enterprise Edition for a while, so I'm pretty familiar with how to deploy workloads into Swarm, but I'm new with Kubernetes. Could you give me a hand?
Absolutely. Luckily, I've been working with the upcoming version of Docker Enterprise Edition, and I can show you how to use the new Kubernetes built-in features.
Okay, so let's see. Now, first, I'm going to need to learn how to install Kubernetes and set up my own cluster, right?
No, that's the great thing. With Docker Enterprise Edition, you're going to get a unmodified version of Kubernetes built right in. I actually have a cluster ready we can use. Why don't you log in?
Okay, let's take a look. Okay, so I can see that there's some changes to the dashboard here. Could you kind of briefly walk me through the highlights on what's new?
Of course. Under a single pane of glass, you're able to see both your Swarm and Kubernetes workloads and how they behave. At the same time, you're able to see all your manager nodes and all your worker nodes and track their status. And if you take a look on the left navigation, you'll see we added some new capabilities there as well.
Ah, cool. All right, so let's go take a look at some of those. All right, so let's see, user management. Okay, so I see I can manage my users, my teams, my access control. Now, are all of these features going to carry over into Kubernetes as well?
That's right. Everything stays the same for your users and your permissions. If you have configured Docker Enterprise Edition to use an external identity provider, such as LDAP or Active Directory, all those users and teams will have access to both Kubernetes and Swarm.
Cool. All right, let's keep looking. All right, so Swarm resources. All right, nice. Those look familiar. Now, am I going to have to make any changes to my Swarm services to have them run in this new environment?
Nope, nothing changes for your Swarm workloads.
Nice. Okay. Let's see, Kubernetes. Okay, so these are the new Kubernetes resources. I guess we'll get back to that a little bit later. Now, shared resources. This is something new. Can you talk a little bit about what that is?
Sure. These resources are shared between the orchestrators, such as containers and nodes. And why don't we dive in a little more into nodes, actually?
Okay. Let's take a look. All right, this looks familiar. So it's my nodes dashboard. So I can see the nodes in the cluster. I can see that this is a highly available cluster with 3 manager nodes running. But where's Kubernetes?
That's the beauty. All manager nodes are running all management components of the platform and serve as both Swarm managers and Kubernetes masters. At the same time, all nodes are capable of running both Swarm and Kubernetes workloads and are secured by a unique cryptographic node identity. That way, it's easy for IT operators to establish a highly available cluster.
Wow, so a single pane of glass, I can see all of my Kubernetes and Swarm workloads, and all of the existing Docker Enterprise Edition features that I'm familiar with carry over to both orchestrators. That's awesome. All right, so let's go ahead and deploy that app. Now, I'd like to use the secure supply chain features of the platform to make sure that we don't have any vulnerabilities getting into production. Now, I know how to do that when I'm deploying a Swarm workload, but do I need to do anything different when I'm using a Kubernetes workload?
Nope, it's the same. You know how to do this.
Okay, all right, let's get to work. So we're going to go over to my trusted registry. Okay, so I see we have our repositories set up for the web app that David just showed us. Now we've made one slight change for the secure supply chain. We've taken the web portion or the web image for this application, we've split it into 2 parts. So we've split it into a dev and a prod version. So the dev version, hold on, let me refresh that. All right, so the dev version is where our CI system or our developers would push the images, and then we would run scans on that before we promote them to production. So let's go ahead and set up a policy. We'll create a new promotion policy. All right, now we want to make sure that no critical vulnerabilities are going to make their way into production. So we'll go ahead and set it to critical vulnerabilities equals 0. We'll add that. And let's go ahead and send it to the prod image. And we'll keep the tag the same for now. That should be fine. OK, so we've set up our policy. Let's go ahead and check. OK, so no images have been pushed yet. So we're going to need to do a build and a push. So let's go ahead and hop over to a terminal. OK, so in this terminal, I've got the web portion of that Words app. So let's go ahead and do a Docker build. Let's go ahead and do a Docker push. OK, so we've pushed our image. Let's go check our registry again.
Uh-oh, it looks like you have vulnerability.
Oh, man. OK, let's see. What are we going to do here? Let's go take a look at the details on that. What's going on? OK, so it looks like the base layer is introducing a number of vulnerabilities. I think we're going to have to go take a look at that Docker file and figure out what's going on. All right, so let's go take a look at that Docker file. OK, so I can see we've got a multi-stage build here.
You're using Alpine 3.2, which has several known vulnerabilities.
Good point. Yep, let's get that upgraded to the latest version, which is 3.6. We'll go ahead and write that out. All right, let's go ahead and rebuild. And let's go ahead and push. OK, so we pushed back to our trusted registry. Now let's go ahead and check our prod repo. We'll check the images. There we go. So we've set up a secure supply chain to make sure that no critical vulnerabilities make their way into our production environment.
Nice. All right, now that our images are ready for production, let's deploy this application. David gave me a compose file earlier, so we can deploy it as a stack, which are now a shared resource. Do you want to give it a shot?
OK, so let's go into shared resources. I can see we've got stacks here. OK, so let's go ahead and do create stack. All right, let's give this app a name. We'll call it Words app for now. All right, let's pick our mode. Oh, nice. So we've got Swarm services, basic containers, and Kubernetes workloads now. Cool. All right, so namespace, we'll use a default for now. Let's go ahead and get that YAML file uploaded. Let's get that Docker compose file. OK, we'll zoom in a little so it's a little easier to see. OK, so we can see that it's basically the same compose file that David showed us earlier. We've just substituted in our trusted registry and the prod version of the web portion of the app.
I heard the more you scale it, the funnier it gets. Why don't you set it up to 11?
All right, let's give that a shot. All right, so I see we've deployed our stack, but now how do I tell if it worked, or how do I actually get to the app?
Yeah, just go to load balancers under Kubernetes,
okay.
And from there you'll be able to see the web service, which will give you the URL for your front end on the right side.
All right, so we've now taken a traditional Docker compose file, and we've deployed that as a Kubernetes workload. Nice. OK, so one of the engineers on David's team sent me this backup tool that I'm supposed to use on this app. And he told me that I need to use the Kubernetes command line tools, and it has a Kubernetes YAML file that comes with it. Now, are those tools and files going to be compatible with Docker Enterprise?
Absolutely. Kubernetes has a rich ecosystem, and since Docker Enterprise Edition comes with an unmodified version of Kubernetes, you can use all of these tools, examples, and documentation. Let me show you.
OK.
So in this terminal session here, we've used the client certificate bundle feature of Docker Enterprise Edition to authenticate both our Kubernetes and our Docker command line tools with our cluster. As you can see from the commands that I'm typing, both orchestrators are able to see the same sets of nodes. For example, this node is both in the Docker and the Kubernetes node inventory. All right, so let's find that YAML file. Here it is. It looks like a standard Kubernetes batch job, which will deploy container once using this image over here. And let's go ahead and create it.
Cool.
All right, this is the standard command to deploy this file using the Kubernetes command line tool.
Okay.
And let's see if it was created on the user interface. we would go to controllers, and as I told you, with Docker Enterprise Edition, you can use both the Docker and Kubernetes command line tools and both the Compose and Kubernetes YAML formats.
Wow, that's really powerful. All right, so we've seen that both Swarm and Kubernetes share the same cluster nodes of inventory and cryptographic node identity. We've seen how to set up a secure supply chain for both Kubernetes and Swarm workloads. We've seen how you can do take Docker Compose files, the traditional Docker Compose files, and deploy those onto Kubernetes. And we've seen how the native ecosystem of tools and documentation and examples and file formats all work against Enterprise Edition.
That's amazing. Thank you.
Thanks.
Thanks. Hey. Pretty cool. Okay, so you're starting to get the idea here, right? We put a premium on integration with both the developer tools and the management tools so that any Docker user anywhere can leverage Kubernetes for development and production without having to throw everything away and start over, right? It's just seamless. And that was the number one criteria. And there's a lot of different ways you can do that. And like I said earlier, we wanted to do it the right way, which means doing it the hard way. This is really not a superficial integration. It's not a wrapper. It's not a fork. It's an in-depth integration at every level of the stack. And to pull off that level of integration takes a lot of hard work, a lot of coordination with the Kubernetes community. And we've managed to pull that off because of the way we develop the platform, because of our open development model. So you remember we talked about the Moby project at the last DockerCon, and the entire development process of the Docker platform starts upstream with the Moby project. It happens in the open, and we collaborate out there with thousands of contributors around the world, some of which are inside this room, and we design and we improve open components. And we arrange them and integrate them in a lot of different ways so that anyone in the ecosystem can do whatever they want with it. Now, we use these components in a really specific way, and we integrate them into products, into Docker CE, into Docker EE. But the whole ecosystem benefits by participating. And that's the model that allowed us to pull off not just a superficial integration, but a real in-depth integration. Because if you look at the individual projects, the individual components within the Moby project, most of them have been integrating quietly in the open with Kubernetes for over a year. For example, Containerd, the same container runtime I've talked about earlier, the 1.0 development started out at KubeCon last year with a group of Kubernetes maintainers, and the topic of the discussion was, what are the ideal specs for the ideal container runtime for Kubernetes? So that's the very foundational component of the Docker platform that started out as an open collaboration with the Kubernetes community. And that's just one example. Another example is networking. Swarm has libnetwork. Kubernetes has CNI. And these are two different standards, two different formats that have been incompatible for as long as they've existed, which has been really annoying for a lot of people in the community. Well, we've quietly worked at that with the community, and now they are interoperable. There is an integration between the two, which means that the container networking ecosystem can now leverage the full strength of the engineering talent out there, not just a fraction. Another example is security. Now, some of you might have noticed over the last few months, there's been a convergence of security features between Swarm and Kubernetes. A lot of the features that appeared in Kubernetes appeared in Swarm. A lot of the features that appeared in Swarm appeared in Kubernetes. You got secrets management, you got cryptographic node identity, stuff like that. And that's not a coincidence. That's because behind the scenes, the security teams that have been designing and implementing these features have been collaborating. They've been exchanging notes, they've been exchanging codes, and as a result, we get more secure orchestration for everybody. Yeah. So we've adopted this model because it's the best way for us at Docker to build the best products for our users. But the beauty of it is the whole ecosystem benefits, right? Because we always get to contribute back more than we get out of it. And we're extremely excited by that because if you think about it, now you have the two largest open source projects in the container universe, Moby and Kubernetes, now collaborating at full speed. You've got components that can integrate, you've got people talking about ideas for how they can work together, and we think that is going to go way further than one more version of the Docker platform. We think it's going to unlock a whole new level of invention and creativity in the container ecosystem, and we're very excited about that. And to talk about this type of collaboration in the open and the potential for it, I'm very happy to welcome another guest here at DockerCon. He's been helping us make this integration possible for over a year. He's a lead maintainer of the Kubernetes project. Please welcome Tim Hawken from Google.
Hello, everybody. Thank you for having me here. This is really exciting. Solomon and to everybody in the room, I would like to say, welcome to our community. This Kubernetes community is something that we've built over the last few years. It's something that I'm really proud of. But as you've heard, this is really more of like a family reunion than a welcome. Kubernetes and Docker go back all the way to the very beginning. In fact, it was DockerCon 1, 2014, when Solomon was up here announcing Docker 1.0. That was the day we announced Kubernetes. And so we have this really shared history. So what does this announcement mean for everybody here? It means that we can collectively, all of us, pull together. We can all pull in the same direction. We can focus on the things that really matter to you guys. It's things like security, ease of use, operational excellence. How do you take your containers and get them out into production faster, more safely, and more easily? This is going to be a fantastic integration for both developers and for operators. And what you saw here is pure Kubernetes. And I want to keep hammering on this point. This is Kubernetes. There's no sleight of hand. There's no tricks. It used the extension mechanisms that are built into Kubernetes to build up from the Kubernetes platform to give you all of the power of the Swarm interface on top of your Kubernetes cluster. So these things can work alongside each other and together. This is just a start. I'm looking for more opportunities for deeper and more meaningful integration with these systems over the coming next years. Now, I mentioned that we have a long history, and you've heard about this. But the truth is, sometimes it's been a bumpy history. Anybody who's paid attention, Docker brought a vision to containers of how simple things could be, how powerful, and Google brought to Kubernetes the experience of running containers at scale in production for 10 years plus. And sometimes these two different perspectives forced us to take different technical decisions. So Solomon, a year ago, came to us and others and said, I have an idea, a big idea. Let's redraw the map. Let's reboot Containerd to build a common core infrastructure that we can build on with both Kubernetes and with Docker and with other systems. It's purpose-built for being embedded into these higher-level systems. So right around that time, our Kubernetes community was building something called the Container Runtime Interface. This is our internal abstraction that hides the details of the container runtime from the upper levels of Kubernetes. And this is an opportunity for us to let our community play with interesting ideas and try to do crazy stuff without having to send us all of their pull requests. And it seemed like Containerd was a really interesting opportunity for us to put that container runtime interface to the test. It seemed like a good fit, so we thought we would try it out. I'm happy to say it works. The Google team and the Containerd team have spent a considerable amount of time this past year working on an implementation of CRI for Containerd. In fact, I think all the main developers are here. Lantau, I know, is in the audience somewhere. He's our primary developer from the Google side of things, and I know the Containerd team is here. This is exciting. It has reached alpha. It means it works in Kubernetes. I don't know if I'd run it in production just yet, but it's there. It's alpha. We're hoping to hit a beta later this year. But more than that, Containerd is exciting for other reasons. It's not just Kubernetes. Like I said, it's other systems that can build on top of it. It understands that it is the bottommost layer in a powerful stack. It is the boring infrastructure. been a lot of noise about boring this year. This is exciting times for boring infrastructure. More than that, one clap from the front. So on top of that, something big happened with Containerd and the Moby project this year. Maybe people didn't notice it. Maybe they sort of flew under the radar. They've announced a change in their governance model. They're moving from the standard model that they've had with Docker for a long time to a more open, community-based governance. This is a big deal. It means that everybody here can now participate in the leadership of the project. And we've done this with Kubernetes also, and I think this is a very big deal. So a round of applause for that big switch, please. So anybody who's been involved in the Kubernetes space knows that Kubernetes and Docker have this history, that we are two peas in a pod in some way. You've also noticed, if you've paid attention to Kubernetes over the last year, that Docker has been more involved. They've been participating in our special interest groups. They've been attending and presenting at our meetups. They've been involved in our mailing lists. We've been working on this thing called the container storage interface, which I could spend a whole hour talking about. Building a common storage API between systems. They've been working on container network interface and adapting the container network model, the Docker networking, into CNI. And they've been involved very heavily in our Cloud Native Compute Foundation, even donating things like Containerd and Notary. This is just the beginning. I'm really excited for the next couple of years. We're going to have a lot of things to work on. There's a lot of work to do, but this demo, to me, is thrilling. So wearing my Kubernetes hat and my Google hat, I think we have a lot of work to do, but I'm very, very, very happy to say welcome to the family and congratulations on this launch.
All right. Hey, stick around. Hey, so I promised that we would take a selfie to memorialize this moment. You're OK with this? I'm asking if you're OK because you're going to be in the background. So if we can get Brendan here also. All right. So thankfully, I always have my emergency selfie stick. Oh. OK, so try to look nice, everybody. I'm famously terrible at this, so. Nope. All right, ready? Everybody say DockerCon.
DockerCon.
Nice. All right, thanks. Thanks again. Thanks, guys. So I want to thank Brendan and Tim one more time for making the trip, and I want to thank their teams also for helping make this integration possible. In fact, a lot of people worked really hard, both at Docker and around the world, on Moby, on the product integration. So if we can have a round of applause for all the contributors. And by the way, there's a lot of open source hacking left to do. So if you're into open source and systems development and you want to participate in the Moby and Kubernetes integrations, there's a lot of different cool sub-projects going on. Come see us. Come see the contributors. You're welcome to come join the effort. So, in conclusion, the Docker platform now supports Kubernetes natively. It's a deep native integration, end-to-end, from Moby to Docker CE for developers to Docker EE for the enterprise. It's coming out on the stable release in the first quarter of 2018. There's a beta coming up soon. You can sign up now at docker.com/Kubernetes. Come ask us questions. Come see the advanced tracks if you want to hear more details. And with that, I want to thank you for listening and wish you a really great DockerCon. Thanks for coming.